together at some of the evidence for global warming and climate change. So we've talked about the greenhouse effect. We've talked about the difference between weather and climate. And we've talked about carbon dioxide. So your first question, number 1, asked you about carbon dioxide. It says Earth's atmosphere now has 416 parts of carbon dioxide for every million parts of air. What does this number mean? So we can click on that. Just waiting for it to move. There we go. Here's what it means. It says carbon dioxide is a greenhouse gas. Too much carbon dioxide in the air makes Earth get warmer and warmer. When humans burn fossil fuels like gasoline and coal, carbon dioxide is produced. This number, so here's your answer, this number tells how many parts of carbon dioxide there are in 1 million parts of air. So if carbon dioxide is at 416 parts per million, or ppm, that means in 1 million particles of air, there are 416 particles of carbon dioxide. So why is this important? We need to keep a close watch on this number. Carbon dioxide levels have gone sky high in the past 100 years. Many scientists think that 350 parts per million is a much healthier number and that we should try to reduce our use of fossil fuels to get that number back. Carbon dioxide over the last 500,000 years, and then carbon dioxide right now. Okay? So answer your question for number 1. For number 2, it says Earth's global average temperature is 2.1 degrees Fahrenheit hotter than it was in 1880. Why is this small number a big deal? So, why is Earth's global average temperature a big deal? The global average temperature combines the temperatures of all the hot places and all the cold places and all the places in between. It's a very important measure of changes going on in Earth's machinery. A rise of just 1 degree Fahrenheit on a sunny day where you live has little effect. But over the whole Earth, a rise of 1 degree Fahrenheit makes a big difference. Just think, normally water at 32 degrees Fahrenheit is solid ice, but water at 33 degrees Fahrenheit is liquid water. So, even a small rise in Earth's global temperature means melting ice at the North and South poles. It means rising seas, it means flooding in some places and drought in others. It means that some plants and animals thrive while others starve. It can mean big changes for humans too. And that's why this number is a very big deal. Let's look at number 3, sea ice. The area of the Arctic Ocean covered by sea ice in 2020 was only about, that's what this little thing looks like, about 56%. So as large as it was in 1979. So it's about half as big as it was in 1979. What is happening to the ice? During the winter, the top layer of the ocean near the North Pole freezes solid. So here's the North Pole, it freezes solid. Every summer, some of this ice melts, but not all of it melts. Some of the ice is so thick that it stays frozen all of the time, even throughout the summer. However, since 1979, when Earth observing satellites began watching, the ice remaining at the end of the summer has been getting smaller and smaller. At the end of summer 2009, the ice was only 2/3 as large as the end of summer 1979. In August 2012, it was the smallest on record. So this is the image from satellite data that shows the extent of Arctic sea ice at the end of summer 2012. The yellow outline shows the average end of summer sea ice cover over the past 30 years. But since satellites began observing, so it's not freezing as much or staying frozen. It's melting way more than it was melting before. So what? The sea ice is an important part of how ocean currents move heat from the equator to the poles and move the cold water from the poles back to the equator. All life in the ocean depends on this energy circulation. All life on land also depends on life in oceans. Sea ice is an important measure of our planet's health. So, sea level is question number 4. The global average sea level has risen nearly 7 inches over the past 100 years. What if it keeps rising this fast? Well, the global average sea level has risen over 7 inches in the past 100 years. A few inches may not seem like much, but every inch of sea level rise covers 50 to 100 inches of beach. If the ice keeps melting, the global sea level could rise more than 20 feet. That would put a lot of coastlines underwater. Whole islands could disappear. As global temperatures go up, ice trapped on land begins to melt and the sea level rises. But something else causes the sea level to rise. Water expands as it gets warmer. As the temperature of the ocean goes up, the ocean actually expands, even without adding any water from the melting ice. Sea level is another important measure of how fast our planet is changing. It's pretty interesting. You can click here to see how NASA satellites are keeping an eye on sea level rise. Also, you can click here that talks about putting a lot of coastlines underwater and that whole islands could disappear. These islands and this place in red would all be flooded, all of these areas, right? So you can't live there if it's flooded. Pretty important.